हरि करना।
Now let's take up. So now let's look into the two-way ANOVA. We have seen one-way ANOVA. Now let's take up two-way ANOVA. So understanding two-way ANOVA in statistical analysis. Two-way ANOVA is an extension of the one-way ANOVA, which allows for the analysis of two factors or independent variables. So it examines the effect of two categorical independent variables on a continuous dependent variable. See that? It which allows for the analysis of two factors or independent variables on a independent variables, and it examines that on continuous dependent variable. So the two independent variables can be nominal or ordinal, and there must be at least two levels or categories for each independent variable. So that's what so allows for the analysis of two factor or independent variables, and it examines the effect of two categorical independent variables on a continuous dependent variable. And what's the condition for the independent variables? So the two independent variables can be nominal or ordinal, and there must be at least two levels or categories for each independent variable. So very complex. So the two-way ANOVA determines whether there is a significant interaction effect between the two independent variables, or whether there are main effects of each independent variable. So a significant interaction effect occurs when the effect of one independent variable on the dependent variable differs across the levels of the other independent variable. So the main effects refers to the overall effect of each independent variable on the dependent variable. The null hypothesis for this one is, the null hypothesis for a two-way ANOVA is that there is no interaction effect between the two independent variables or main effects of each independent variable on the dependent variable. There are two conditions. One, there is no interaction effect between two independent variable, one, or main effects of each independent variable on the dependent variable. Okay, so now that is our null hypothesis, and alternative hypothesis is that there is a significant interaction effect or main effect of each independent variable on the dependent variable. So now the output of a two-way ANOVA includes f values, p values, and degrees of freedom for each independent variable, as well as the interaction effect. So additionally, post hoc tests such as a Tukey's HSD test or Bonferroni correction can be conducted to determine which levels of the independent variables are significantly different from each other. So overall, a two-way ANOVA is a powerful tool for analyzing the effects of multiple independent variables on a continuous dependent variable, and is widely used in many fields including psychology, medicine, and engineering. Okay, now let's take up an example for this. So let's look into the one example. Suppose we want to investigate the effect of two factors. One is temperature and humidity on, let me put it in two, just a minute. Humidity on the growth rate of a plant species. So you got your dependent variable, sorry, independent variable, and dependent variable. So now we conduct an experiment with three different temperature levels. So the temperature levels here, let me put the categories here. So three different temperature levels: low, medium, and high. And similarly, there are two more categories. I think it's here we have again humidity levels. Also three categories: low, medium, and high. So, and we measure the growth rate of 10 plants for each combination of temperature and humidity. So our data somehow looks like this. Let me call upon the plant data, and this is how it looks. So temperature, humidity, and growth rate. This is our continuous variable, and this is humidity, which is categorical variable. Temperature, again a categorical variable, obviously low, medium, high. So this will have a certain order, ordinal variable. So this is what our data, as we have discussed here, examines the effect of two categorical independent variables on a continuous dependent variable, and the two independent variables can be nominal or ordinal, and there must be at least two levels or categories for each independent variable. Hence, conformed, your dependent variable growth rate is continuous. Your independent variables temperature and humidity or ordinal variable with three categories each. Hence you can apply this two-way ANOVA. So this is what is our data. Now let's perform a two-way ANOVA on the data using the stats model library. So let's import stats models from that app.api as sm, then from stats model dot formula dot api and import ols, the most important one. So now let's load the data. So data is equal to pandas read csv and plants.csv and execute. Yep, no issue, data has been loaded properly. Then it's time to fit the model. Let's fit the model. So model is equal to OLS of growth growth rate underscore, let me check, yeah, growth rate and C of temperature plus C of humidity, oh sorry, humidity plus, and our final one, temperature again this time, humidity and data is equals to data, and then fit the old model. That's it. So the fitting is done. Let me just execute and check is there any issue. So unterminated the string. Okay. Yep. The model has been fitted properly, no issue at all. Now it's time to print the ANOVA table. So print sm.stats, and then from there I'm gonna take ANOVA LM and then model, and type is two-way. Type is two-way. So the color has to change to 2. That's okay. Model type is equals to two-way. Yes, here is your ANOVA table. Here is your ANOVA table. So if you look into this, so far let me explain what I have done. So the OLS method or function specifies the formula for the model, which includes the growth rate as the dependent variable and the two independent variables, temperature and humidity, as well as their interaction term ANOVA LM, ANOVA underscore LM. So the ANOVA underscore LM function then prints the ANOVA table, which shows the F values. You see that F values, and then you can see the P values and degrees of freedom DF, each for each independent variable and the interaction effect. So the output of the two-way ANOVA would look something like this that you can see on screen. So from the ANOVA table, we can see that both temperature and humidity have significant main effects on growth rate. You see that? On growth rate. Temperature and humidity have a significant main effects on the growth rate as their p values are less than, you see that their total p values are, it's multiplied, it's 10 power minus 17 and 10 power 9 and this one. So as it's their values are much lesser, so that's the reason. So as their p values are, if you see that these are as usual normal, as their p values are much lesser than 0.05, the temperature and the humidity, so both has a significant interaction effect between the temperature and humidity as indicated by the p value for the interaction term. So this is the specific interaction, and that's also lesser. So finally what we can tell from this is, we can see that the both temperature from the first two variables, both temperature and humidity have significant main effects on the growth rate as their p-values are less than 0.05. And additionally, not only that, you can tell you have a large f statistic. F statistic is large, you can tell that. Then in additionally, there is a significant interaction effect between the temperature and humidity as indicated by the p-value for the interaction term, and this is what the interaction term. So post hoc tests can be conducted to determine which levels of each independent variables are significantly different from each other. For example, we can perform Tukey's HSD test to this.